There are 8 billion Earth-sized planets out there in the Milky Way, but you've probably never heard of any of them. That's because they read all about the size of the planet Mercury and invisible to the naked eye. But there is one place where we can see these tiny worlds up close: Saturn's rings. Now, astronomers have found that these rings aren't just made of ice, but also countless little moons, including some that are also the size of Mercury. But even though these so-called shepherd moons help keep Saturn's rings from collapsing, they don't have enough gravity to explain why the rings look so sharp. So, scientists are now searching for an even tinier moon on the inside of the rings, one that would be smaller than even Pluto. It might seem like a far-fetched idea, but I think it's pretty cool that we're thinking this way, and I know what you're thinking. If there's another moon inside the rings, will it be one of those little green guys from Avatar? No, it won't be that. There won't be any Na'vi moons. But there could be something even better. On April 27, 2023, the European Space Agency released the first beautiful image taken by the brand new James Webb Space Telescope of Saturn's rings. The picture shows the outer edge of the Keeler Gap, a 350-kilometer wide break in the rings. Astronomers have known about this gap since 1960, when NASA's Pioneer 11 spacecraft took the first pictures of the rings. They knew the gap was there, but they couldn't see how wide it actually was or what was causing it. The prevailing theory was that two small shepherd moons were keeping the gap open. And JWST confirmed there are 2 moons, but it turns out they are much closer together than astronomers thought. What's more, the moons, named Prometheus and Pandora, appear to be much darker than expected. Scientists think they are covered in water ice that has been reflecting very little sunlight. But the biggest surprise was that Pandora and Prometheus didn't seem to be big enough to keep the rings apart on their own. Each of the moons is only about 6 kilometers across, and even though they orbit Saturn in different directions, they each exert only a paltry 0.002% of the gravitational force that Earth exerts on us. That's enough to affect small objects like dust particles, but not enough to move large chunks of ice. So if they aren't strong enough to keep the ring clear on their own, how do they do it together? Well, for starters, they are actually orbiting a little further away from the gap. They're more like shepherds watching over sheep, guiding them without ever stepping inside the pen. As the moons make their 40-hour orbits around Saturn, their gravity pulls on the surrounding ice, creating small humps on either side of the moons. These icy humps prevent the rest of the ring from drifting too far outward and collapsing. At the same time, the middle of the ring is dense enough to pull material inward towards the planet. But in order to get this collapse under control, you need a strong downward force, something that a couple of 6-kilometer moons can't really provide on their own. So the question is, what other forces could be at play here? One possible answer is that the tiny bumps created by Pandora and Prometheus are actually bigger than expected. That might sound crazy because the moons are so small. But remember, gravity doesn't depend on mass alone. It also depends on distance. The further away an object is, the weaker its gravitational field is. If the icy clumps are humps, they would stretch for thousands of kilometers. And even though each clump is only a few meters wide, their combined gravity could add up to something substantial. The trouble is, this scenario doesn't explain why Pandora and Prometheus are so dark. Scientists think this is because the ice on the moons has been blown away by charged particles streaming out from Saturn's atmosphere. But if the icy humps are thousands of kilometers long, shouldn't they be getting blown away too? Well, maybe they are. But if that's true, then the gaps between the humps would be so wide that they would collapse and release a bunch of ice into space. So unless these humps are magically repelling the charged particles, they shouldn't exist. That means there has to be another explanation for the gaps. And according to Matt Tiscareno, an expert on Saturn's rings at NASA's Jet Propulsion Laboratory, that explanation is hiding right in plain sight. In his view, the answer lies within the rings themselves. And it's there because we've never seen anything like it before. To explain his theory, he's going to take us back to 1980 when NASA's Voyager 1 spacecraft flew past Saturn and returned the first close-up views of the rings. One of the images showed something strange, a narrow, bright band cutting across the rings. At the time, scientists had no idea what it was. But later analysis revealed that it was a wall of ice more than 100 kilometers high. They named it the Shepherd Wall after the mountains on Mars because it looked like a crumpled piece of paper that had been squished up with a pencil. At first, researchers thought the wall was just a random feature. But by 1981, astronomers realized it was moving. It turned out that the wall was actually a whole bunch of small moons orbiting Saturn in a tight little group. Since then, scientists have identified more than a dozen shepherding groups, each with their own wall. But until recently, they assumed that all of these groups were made of roughly the same stuff, ice and rock. In 2019, though, a team of astronomers analyzed the composition of one of the shepherding groups, and it turned out that the moons were mostly pure water ice. This was shocking because, like the moons Pandora and Prometheus, they were incredibly dark. They reflected less than 5% of the sunlight hitting them. This led researchers to hypothesize that many of the inner moons in Saturn's rings aren't rocky bodies at all, but giant balls of ice. And if that's true, then instead of looking like a crumpled sheet of paper, the Shepherd Wall should look more like a sliced loaf of bread. Individual slices sliding past one another. In fact, radar data collected by the Akatsuki spacecraft in 2014 suggested that the walls weren't solid at all. Instead, they were shifting around like a pile of dry leaves. And if you look closely at the image taken by JWST, you can see that the wall isn't smooth. It's actually made of countless little ice cubes. Astronomers think each of these ice cubes is its own little moon, only tens of meters wide. And that raises a fascinating question. What are they made of? After all, scientists haven't collected samples from these inner moons, so we don't know for sure. But judging by the amount of sunlight they reflect, most of them are probably pure water ice. But some may be pieces of a mysterious substance called water ice, and this stuff is completely different. While regular ice forms when water vapor condenses in space, water ice is formed when organic molecules containing carbon react with water. We don't know exactly what these molecules are, but we do know that they absorb visible light, giving water ice moons a dark appearance. That explains why the moons are so dark, but it doesn't explain why they're so small. To solve that mystery, we're going to head over to Neptune's rings. Unlike Saturn's rings, Neptune's rings aren't very wide. That's because they are being crushed together by the planet's gravity, which is 18 times stronger than Earth's gravity. But if you want to crush something, it helps to have something to crush it with. So, to understand how Neptune's rings stay narrow, astronomers studied its largest moon, named Hippocamp. As it turns out, Hippocamp is only half as massive as the rings it's orbiting, which is weird because moons are usually more massive than the rings they influence. In fact, that's why scientists think something is holding the rings on Neptune together. It's like when you try to hold two magnets together. Even though they're repelling each other, if you bring them close enough, they stick together. In this case, the magnets are the rings and the glue is an unseen moon. Because if Hippocamp is only half as massive as the rings, then there must be some hidden mass keeping them together. Scientists estimate that the total mass of the rings and Hippocamp is around 330 billion kilograms. But Hippocamp makes up 99% of that mass. So the rings themselves are only 3.3 billion kilograms, give or take. And that's about as heavy as 1 million school buses. And that's despite the fact that the rings are 650 kilometers wide. In other words, the rings are only 1 meter thick on average. Now, that doesn't mean they're perfectly flat, but it does mean that they're way thinner than they are wide. It turned out that in order for the buses to stay together, the moon would have to be between 1 and 2 kilometers wide. Or maybe this is just another example of scientists arguing over nothing. What matters is that we're learning more about Saturn's rings than ever before. It was filmed especially for the documentary using a robotic dinosaur skeleton. You can only watch the documentary on Nebula, which is the best place to watch all your favorite educational creators. So please consider signing up today. It really helps support us and our partners.